Now we're going to get into the tips for complex questions, and there are a lot because integration by parts can get really complex. Um, if you're new to integration by parts and your brain is already kind of hurting at this point, that is okay. Um, maybe just like save the slides or take like a screen snip or copy paste or something like that. Pop these in your notes for later. But if you have already gone through integration by parts, or you're pretty comfortable with it already, these tips will definitely be helpful for you when you are going through complex questions. Another thing that I recommend is if you are more of a high achieving student, something that you can really do to elevate your marks is when you're going through the complex questions that you're practicing, make sure that you're writing down the strategies for doing those complex questions, because sure, it absolutely is useful to just do them and get an intuition. In fact, that's the main part of it. But when you have like a whole year's worth of content for to remember for your external, it really is helpful if you just have like a document of all of the tips for complex questions for like specific areas such as integration by parts, to just have a quick read through of like the days before your exam. Okay, so the general tips that I have for integration by parts. The first one, and this is kind of the more widespread one, is that you may need to use integration by parts multiple times. And this is where what happens is you're applying your formula and you get your integral is like equal to like, something plus the integral of like something else, right? Maybe you have like A and the integral of B. So we just applied our formula, we've put everything in, but we still can't integrate this part here. It's better than it was before, but we still can't integrate this part. What we need to do then is apply integration by parts to this integral here. And this is where the integration by parts can get like really complicated. And it's like kind of, you start integrating something and then you think you're going really well, and then you finish it and then you realize you need to integrate by parts again, and then you finish it and then you realize you need to integrate by parts again, and it's like, but, that is kind of the struggle with integration by parts. So an example of this is if you are asked to find the integral of the product of x squared and cos x with respect to x. If you let u equal x squared, which would be a good idea, right? Because the u is the polynomial. So if we do integration by parts enough times, it's just going to derive down to be left with, a constant number. You would still be left with trying to figure out the integral of 2x cos x. And from here, you would need to let u equal 2x and integrate by parts again, because after this point, you would then be left with your derivative being a constant number, which means you're not going to have the product of two functions in the integral. And then again, this tip here is to make u the polynomial part, because then u dash is constant if you, it says integrate, but it should be derive, if you derive it enough, meaning that eventually there's only one other function in the integral part of the formula. The other thing is if you make u the function to a power, it will eventually just derive down to just the function to the power 1. So if you have, say, sine squared x, if you let u equal sine squared x and you do integration by parts, you will eventually be left with a function with only the power 1, which often is much easier to integrate because then you don't have that power. If it doesn't make sense for a question to expect you to integrate something, like perhaps integrating ln x, this isn't a perfect example because in some cases with integration by parts we do integrate ln x. It depends, as I said before, on how many marks the question is worth. If it's a big mark question, then you might be expected to do that, but if it's not, then it's probably something simpler. Um, but if it doesn't make sense, then that's probably u, and the other term is dv dx, or v dash. Okay, the other tip that I have um, is if you have integrals where you have a trig function multiplied by another function, such as like a polynomial, an exponential, whatever, you can keep integrating by parts until you get two terms with the integral that you wanted. Then you can collect them as like terms and simplify. This is kind of like if you ever like do this yourself, or if you've done this kind of question before I explained this part to you, it's kind of like the biggest like aha moment ever when you're doing an integral and you're like, whoa, I can just use them as like terms, like I don't even have to do the integral. It's so exciting. But an example of this is what we have here, where we have the integral of e to the x and cos of 2x. So typically, you wouldn't let u equal e to the x. Or you wouldn't even really do much with the e to the x because the integral and derivative are just like always going to be the same. It doesn't really help much, right? So even though this doesn't get rid of the e to the x in an integral, cos and sine cycle around when deriving, so you can just collect terms. So applying this down here, the integral of e to the x cos 2x, what we have up here, if we let u equal e to the x, we are going to have u, which is e to the x, multiplied by v, take u dash v, and then by integrating this second term here, we're going to have a product of e to the x and cos 2x again. So even though we don't know how to integrate this, we're kind of like, we've got exactly what we started with, but what we can do is take this over here and add them as like terms. And then on the left-hand side, we're going to be left with the integral of e to the x cos 2x, which is what we wanted to find. And on the right-hand side, we're going to have an answer. So it just seems like one of those things where like you kind of feel like you shouldn't be doing it, or it shouldn't work, but it does, and you can do it. So, I mean, breaking the rules, I guess. So yeah, that's just like another interesting and kind of fun and cool tip that you can do, is you can collect the like terms if you find that you actually just can't integrate this certain part and it just kind of keeps coming around. Okay. So in this section here, we need to solve the integral of ln x. This is a pretty standard complex question, or something that maybe your teacher will give you in class as kind of like oh, try this, you won't be able to do it. But once you know the trick, it's actually very easy. And of course we have this Star Wars meme, when you integrate by parts, but the resulting integral has to be done by parts again. That's actually very frustrating. You've become the very thing you swore to destroy. Very accurate. So, for integrating ln x by parts, what you actually need to do, and if you don't want to know the answer yet, pause the recording, have a guess, but I'll tell you guys the answer now. What you actually need to do is you need to let u and v dash equal certain things. So we have a product here. Well, not necessarily a product, because a product is two functions. But we have like a multiplication here, right? So we know that one of them is ln x, and the other one is 1, because this is technically like 1 times ln x. So if we derive ln x, we're going to get 1 on x. If we integrate 1, we're going to get x. But now we can apply our formula. So we're going to apply our formula. So for integration by parts, we're going to have uv, so x ln x uv, minus the integral of v times u dash. Of course, this is just going to cancel to 1, right? So we now have x ln x, take the integral of 1 with respect to x, which just gives us x ln x, take x plus c. So this is our integral of ln x. Now again, this is kind of like a trick question, so to speak. Once you understand the trick, it's actually really easy to do, but it is useful to know it in case you come across it in a question. Especially if your teacher hasn't taught you it in class, it might be likely that they'll kind of think that this is like unfamiliar to you, so it's like a trick to know.